Hey guys, welcome back. We are now doing AMC 10A 2022, problem number 23, which I believe is also on the AMC 12. Sorry, I have to be more prepared with this. It is number 20 on the AMC 12. Okay, so it's also there. Now, this I found to be one of the harder problems on the whole thing. I definitely struggled with this one for a while. Took me a good bit to kind of get the idea of the problem. Like every AMC problem always has like, oh, this was the idea they were going for, and finding that idea in 3 minutes is almost impossible. So it takes you time to like really work it out, think about it, look at it for a while. Sometimes it takes a couple of hours to look at this problem and say, oh, this is what they were going for here. Isosceles trapezoid ABCD has parallel sides AD and BC, with BC less than AD and AB equal to CD. There is a point P in the plane such that PA equals 1, PB equals 2, PC equals 3, PD equals 4. What is BC divided by AD? Okay. Well, as you can see, I have a lot of work here on here. I just find it easier if I just pre-explain what I'm doing. So if you look at BCD, point P is 3 and this distance is 4. What I've done is I've drawn an altitude from point P to line BC, right? And I've split the two pieces into part A and part B, right? Now, because it's an isosceles trapezoid here and then split this also into a right triangle, these distances would have to be the same. Like, so this sort of extra distance here, like if I were to draw this altitude here, this little distance, I could call it X, right? And then same thing, if I were to draw the altitude from C down to here, I could call this little distance X. You can call it C and D, but it actually just makes the math easier. Sort of. Now notice how this right triangle PA, I mean, I can give this a name, I guess F, right? Triangle AEP and triangle DEP both share PE as a common height. So by using Pythagorean theorem and then setting the equal parts equal, I can say that 1 squared minus a plus x squared would be equal to this distance squared, right? 4 squared minus b plus x squared would be this same distance squared. So therefore 1 squared minus a plus x squared equals 4 squared minus b plus x squared, right? Now looking at this right triangle here, so BFP and CFP, right? This right triangle here, this long one, and then this one, right? Same reasoning. I can look at this whole red distance as being equal between the two right triangles. So I can say 2 squared minus a squared is equal to 3 squared minus b squared, because they'll both equal the red distance squared, right? So by sort of manipulating these two equations, I end up getting b plus x squared minus a plus x squared is equal to 16 minus 1, 15. And then b squared minus a squared is equal to 9 minus 4 or 5, right? Now think about it. What is it that I'm trying to calculate? I'm trying to calculate a plus b over a plus x plus b plus x, right? So what I can do is notice how each of these equations is a difference of squares. B plus x squared minus a plus x squared is 15. I can write that as b plus x times b plus x minus a plus x is equal to 15. And then by rearranging that formula, I would get a plus x plus b plus x equals 15 over b plus x minus a plus x. And then similar here, b plus a times b minus a is 5. Or b plus a plus b. Now I have expressions for a plus b. And so in other words, I have expressions for line BC and line AD, right? 5 over b minus a and 15 over b plus x minus a plus x. But notice how here, this equation simplifies, the x's can cancel out, and you just get 15 over b minus a. So by finding the ratio of a plus b and a plus x plus b plus x, I end up getting 5 over b minus a over 15 over b minus a, because again, those x's cancel. So you'll have 5 over b minus a over 15 over b minus a. The b minus a's can cancel. You're left with 5 over 15. 5 over 15 reduce Pythagorean theorem, and extra pieces are going to be equal because it's an isosceles trapezoid. So that's sort of the trick to this one. But otherwise, it's actually a pretty tough problem. I actually set up a whole thing using cosine, like the law of cosines, and setting up, and it just takes you sort of nowhere. So a lot of these problems, like you have to just sort of know the strategy going in. All right, I'll see you for problem 24. See you later.